Okay. Yeah, if one of you just can keep it. Okay. But we have extra time.
Yeah. Well, let's try and stick to it.
Hello, guys. It will be time to start. If you can just sit down. Ali, Danny, Keyo, please sit down. Okay, so this is the best session in Montreal. Thank you for joining in this very, very, very big room for an unfortunately small audience. Let's start with our chair update. No, oh, yeah. I think Monkamana cannot join, so we may need to find a note taker. Does anyone want to help with taking the notes? Krishna? Yeah. Thank you. Okay, so this is our notewell. So if you are not familiar with it, please read it. A couple of meeting tips. So if you are a usual attendee at the IETF, you should already know about that. When you want to talk and you are on site, ensure that you're signing into the Meeteco so we can track your attendance. And if you want to join the queue as well, please use the Meeteco app so we can have fair sharing between on-site and people that are remote. And for remote participants, just unmute yourself when we allow you to speak, please. So this is our agenda. So for this time, it's not fully packed. So we may have time for discussion. Status update about the documents. So we have one new RFC which has been published since the last IETF, which is the multicast source redundancy in EVPN. We don't have any additional documents which are in the RFC editor queue yet. However, we have 3 of them which are still either under Gunther or the ISG review. We have this very old EVPN, IPVPN interworking draft that ideally we want to push quite fast. So yeah, I think Jorge, you have the pen on this one. So you need to close the updates from the AD. Yeah, go ahead.
Yeah, Jorge Rabadan. Yeah, I am on basically halfway on my reply to Gunther out of his 120-page review email. So
thank you, Gunther.
Yeah, it was a very good review. Thank you, Gunther. It was very nice, but yeah, hopefully I'll have it done this week. So thank you.
Thanks a lot. So the next one is the MVPN, EVPN, SRP2MP. So again, we have a couple of discuss from the ISG that needs to be sorted out. You want to say something?
I just want to say one thing about one of the discusses is actually on the naming of a field that's named MPLS label currently, but it's carrying MPLS or SRv6 SIDs. And I think one of the ADs has said that this really needs to be looked at, this naming, and it may involve updating the source RFC for that as well. So we can have a look at that offline and work out how to take that forward.
Okay, and the last one is the EVPN unequal cost load balancing. So thank you, Jeff and Niraj, for closing the discussion. So hopefully we will get few comments from the AD and ISG. We will see. We have a couple of documents that are still, I would say, under Shepherd review. So we have this very, very old VPLS multi-homing draft, Kiriti. Kiriti, thank you for being here. So we really need your help to be able to close and ensure that you will be able to follow up on the final process to edit this document.
So Kiriti compiler HPE. C'est un peu drôle, mais c'est vrai. Okay, so the answer is 0. I don't know what the question is, but the answer is 0.
So my question is, will you be able to keep answering all the questions and concerns that the ISG may have through the publication of this document?
Yes. So the first question was raised by someone from Cisco. What should the local administrator field be in the community? And the answer there is 0. But I will send an email replying to that. Jeff is actually advising me because I have no clue about BGP. So I will reply to the email, but then I will update the document with that. And then, yes, if there are further questions or updates that are required from the RFC editor or whoever, I will respond to that. Hopefully in a slightly more timely fashion.
I'll probably do another Shepherd's review of it because it was such a long time ago and there's bound to be things that need to be changed and fixed and updated to keep the ISG happy and so on.
Right.
So
cool. Thank you.
So next one is the EVPN Geneve. So I think on this one, we still have issues getting refresh from Sami and helping moving this document forward. So yeah, we will discuss, I would say within the chairs, but at some point, if we are not able to get Sami being able to move this forward, we may need to find some other editor.
So I did get a message from Sami offline saying that he would pick this up again. But we really do need to move ahead with this now and just get it done, I think.
But we really need to ensure that you will be able to follow up through the entire process, not just one time. Okay, and the other one is EVPN BFD. Jeff, you already have a comment? No, go ahead, please.
So Jeff Haas wearing my BFD hat instead of my BGP hat. I am seeing good discussion about a number of no small issues in there. I think I have one or two minor, very, very minor edits on my side to also forward off as part of the discussion, but it seems like it's moving to conclusion fairly well. I think the one open big question is what to do about the port number that's involved. And the problem is I haven't spent a huge amount of time looking at how the technology is being deployed, but based on my understanding of the conversation, the concern is legitimate. It might be able to be possible to confuse these packets in some circumstances, especially if the encapsulation breaks in the middle for a standard BFD session. And this means that it'll land as a single hop BFD, confusing the implementation. So I'll finish my audit of the scenario and send off recommendation, but I think at the moment, everybody's already on the right page. We probably need a different port. That's the easy answer.
Okay, thank you. So we still have a couple of documents that may be ready for working group last call. So we have 2 drafts about BGP multicast. I think there was still some pending discussion with Sue on this one. Yeah. So yeah, Sue, if you want to say something.
Hi, guys, I've had a personal outage for about 4 months. So I will attack each one of the multicast controller and multicast chairs once if IETF is over.
Okay.
All I can do is apologize, but I will do that. And again,
Yeah.
I'm sorry for that.
Okay, thank you. And the other one is the EVPN MVPN seamless interop. So on this one, we just need, I think the authors need to check with the reviewers that they are fine with the modifications that have been done. We still have a couple of documents that we may evaluate for working group last call. We have this EVPN AC aware bundling. I think, Jeffrey, you are still discussing with co-authors on this one?
Right, we still need to close some issues, and we will be talking about those issues here offline.
Okay, we have also the Perflow DF election, extended EVPN optimized AR. So at some point, I wanted to do the working group last call on this one, but the draft was expired, so it's not. It has been refreshed in the meantime. So if the author still thinks that now it's ready to go, we can probably proceed in the near future with the working group last call. And yeah, our goal is also to go to working group last call as soon as we can for the 7432 BESS. Yes, when, please?
Hi, from HP, when the extended the EVPN.
Can you speak a little bit louder if you can?
Hello, can you hear me?
Yeah, a little bit.
Me
No.
at all.
Otherwise, try with another mic. Try with the other one.
I think it works right now.
Oh, yeah.
Thank you.
Yeah.
Thank you for the help. I just want to mention extended EVPN optimized IR draft has been updated. Yeah, thank you. So,
Okay, cool.
Yeah.
And you think it's ready now for working group last call, right?
thank you.
Yeah. Yeah.
Okay, so for the 7432 BIS drafts, I need to do some work. I did my initial Shepherd review. I've seen updates and responses from the authors, but I have to admit I have not got a chance to follow up on those. So I will finish those and then we'll move to the next step.
Okay, so ongoing call for adoption. So we have this L3MH proto. So I think just before the meeting, you told that we should be good to go.
Yes, officially the call ends tomorrow. I have seen all the co-authors responding with IPR declarations and things like that. I also seeing good support, no objection. So I'm sure that we will be able to adopt it by tomorrow.
The other one, UMR mobility. So theoretically, the adoption call was closing sometime last week, but we missed a couple of IPR replies from some authors. So it seems that this week we got some replies, but unfortunately we still miss some IPR replies from a few of them. So as soon as we get them, we should be also good with the working group adoption. Yes, please, Jorge.
Sorry, I didn't go into the queue. No, I just had since we have some time, I wanted to ask a question to my three favorite chairs about the working group adoption calls. Are you guys updating the wiki when you have candidates for?
Well, unfortunately, no, we are not really good in updating it, so it's not fully accurate.
Okay. No, my question was because we have a bunch of documents for which we requested working group adoption call. So if we go to the wiki and we don't see it, it's not that it's not under your radar.
It should be there. Okay, so if it's not there, don't hesitate to ask again to ensure that it's tracked, because we are actually using that as a kind of source of truth.
Gotcha. Thank you.
So some of our document that we may consider soon for working group adoption. So we have the MUP SAFI. So we got the adoption request from the authors a long time back, but this document was also waiting for the architecture document in a DMM working group to be adopted, which is actually done now. So I don't think we have any issue anymore on this one.
No, there's no issue on this except it's expired. So we can't we can't progress things if they're expired.
Okay, Patel, Arcus will refresh it.
Thank you.
And the two other ones are the EVPN First Hop Security and the EVPN IP MAC Proxy, and we will have a presentation on this one today. Something we are not super happy with is how authors are progressing or not progressing the working group documents, because we still have something like 16 expired working group drafts. So we really see that, and it's not the first time we say that to the working group members, but there is a lot of traction for the authors to get to the adoption, and things are moving fast. But as soon as the document is adopted, it's not moving anymore. And we have to, I would say, chase the authors to ensure that we get updates, comments are replied, so we can actually move the document up to the publication. So we really need to get your support in moving the document forward, because sometimes I would say authors are putting pressure on us to review the document, move to the adoption, and so on, but then we don't have the counterpart, which is, I would say, replying to the comment on time, so we can have some good pace and fast updates of the document. And clearly, and this is something that I mentioned earlier about the GNIF draft, if at some point we see that there are some critical working group documents that are not progressing, and as chairs, we want to progress them, we will likely appoint new editors that will make this document progressing faster. One other thing that we want to clean up is many years back, I don't even know, maybe it's more than 10 years, we started to reevaluate some of the working group documents that haven't progressed for a long time. And as a working group, we decided to park some of them. I don't think the situation has really changed, but we will evaluate with, of course, the support of the working group, the possibility to just mark them as dead. So likely we will just do some poll to see, for instance, if someone is now interested to move this one of these work forward, and if it's not the case, we will just mark this document as dead. Working group milestones, I don't think we have any updates since the last IETF. For now, we are still on time. So VPLS multi-homing, we have, I would say, a milestone to get this to AESG by December. So yeah, let's try to make this working.
I just wanted to have a note about the Yang models as well that we have, the device Yang models, because we added these as milestones when we did the last charter revision, and it turns out that there's actually some Yang models in other working groups that are dependent on these EVPN Yang models, like there's one in NVO3. So these are currently parked, I think, but it would be good if you'd like to pick them up again. I think I already spoke to the editors of the L2 VPN Yang, but there's a few others. So if the editors are interested in picking those back up again, we can. I think previously when we parked them, there wasn't a huge amount of interest in progressing them, and we had a big backlog of other working group documents to progress. Now that queue has somewhat cleared, I think it's good to see if people want to pick that up again.
Okay, so I think we are good. So first slot is eBGP DMZ, and I'm the presenter. Okay, so this is an update about the eBGP DMZ draft, which is also a kind of old one. Just as a reminder, so the initial focus was on some use case that was mainly, at least at the beginning of the draft, driven by a data center on how can we leverage this BGP link bandwidth community, which has been defined in the IDR working group to provide efficient weighted load balancing in the data center. So this is involving two things. How do we actually tweak the WECMP, but also how can we automatically set some value to this BGP link bandwidth community? So what are the main updates that have been done? So a lot of things happened recently on the BGP link bandwidth draft in IDR. And on the counterpart, this eBGP DMZ draft text wasn't really evolving for a long time, which means that there was a big disconnect in some things that were told in the eBGP DMZ draft and that were not accurate anymore. So there was some assumption about, for instance, the BGP link bandwidth community not being able to be sent one time over eBGP, but now everything is addressed as part of the BGP link bandwidth draft. So we had to clean up all this inaccurate text. The other thing is, in the older version of the document, we had some of the behavior, like for instance, this accumulation that I will describe just after, which was really mixed up with the various use case. So what we have done is we have really splitted the various use case. So it's just a subset, and maybe some people could come up with additional use case that we could have in the draft. And on the other side, the behaviors. So we really have a differentiation between use case on one side and how we address them with some specific behaviors. And the current behaviors that we are defining in the draft and which are reflecting what is actually deployed in the field is, first of all, the ability to automatically set the BGP link bandwidth attribute based, for instance, on discovering the interface bandwidth over which the eBGP directly connected peering is established. How can we tweak the WECMP by, for instance, using, I don't know, as a use case that I will present after, a minimum between the bandwidth that I'm receiving in the attribute, but also the bandwidth that I'm discovering from the interface. And we have also the accumulation use case. So this document was informational at some point. We are wondering if we should make it back to standard track. So this new version is back to standard track, but again, it's up to discussion. So one of the biggest use case, but not the only one, about the BGP link bandwidth extended communities is how we can handle efficient weighted load balancing in data centers. So for instance, here we have two data centers, DC1 on the left side, DC2, which is, I would say, abstracted on the right-hand side. So DC2, for instance, is sending some aggregates representing all the IP addresses that are part of this data center. So there is a BGP update which is sent for this aggregate address up to the aggregation routers that are interconnecting multiple data centers together. So for instance, campus-wide aggregation. And of course, then the aggregation routers will have to tell to the tier 1 router in DC1 that they are able to reach this aggregate with a particular bandwidth available. So let's say AG1 router is able to reach the aggregate with a link bandwidth which is X1, and AG2 is able to reach it using a bandwidth which is X2. Same thing, the T1 may have to do something and tell to the T2 that it may be able to reach this aggregate with another set of bandwidth, okay, and so on down to the data center hierarchy. And again, the purpose of this draft is how can we perform WECMP efficiently at all the stages of this data center. So the first thing is, as I was saying, how do I initialize the value of the BGP link bandwidth? And one of the mechanisms that this draft is bringing is automatically discovering the bandwidth through the interface bandwidth. So basically, I have my eBGP peering between, for instance, AG1 and DC2. AG2 has also a BGP peering to DC2. And this peering is created over a particular interface. So for instance, AG1 is using 800 gig, and AG2 is actually using a bundle of 400 gig, so 4 times 100 gig. And unfortunately, let's say one particular link is in this bundle is actually down. So by having BGP discovering the interface bandwidth, AG1 router may be able to set the link bandwidth community when advertising to T1 with a link bandwidth of 800 gig, and AG2 will send 300 gig because we have a bundle of 4 times 100, but one is actually down. And of course, as I was mentioning, this is a kind of dynamic tracking. So if the interface bandwidth is actually changing, we need BGP to be notified. So a new update will be sent with a new bandwidth value. So this is the first mechanism, how we can actually discover the bandwidth used through the interface. The other consideration that I was introducing is how can we actually tweak VW ECMP. So if we look at again what happened in the earlier step, so we had AG1 sending a link bandwidth of 800 gig to T1, and AG2 was sending 300 gig, okay? However, if we look at it from T1 point of view, for instance, we can see that T1 is actually connected to AG1 by a link which is, let's say, 600 gig, okay? And T1 is connected to AG2 using actually a link which is 400 gig. So if, let's say, T1 is doing its WECMP as it's described in the base link bandwidth draft, it will use the actual link bandwidth extended community, so it will compute the weight based on 800 and 300. Okay, but if we do that, what will happen is actually we may create a congestion because we may send too much traffic to AG1, and to AG1 we have only 600 gig of bandwidth available, okay? Which means that in some particular cases, we need also to take into account what we can call the local bandwidth, in addition to the bandwidth that I'm receiving from the from my BGP peer. So this is why we come up with some definitions. So we have the remote bandwidth, which is the actual bandwidth that we receive in the BGP update through the BGP link bandwidth community. We have the local link bandwidth, which is the bandwidth that we actually discover from the interface. And then we define in this draft a new notion, which is the contributing bandwidth, which is the actual value that we will use to do the WECMP. Okay? And then where does this value come from? It could come from, I would say, we can say that I want to use, for instance, only the remote bandwidth. I could use only my local link bandwidth, and I don't care about what I receive from my peer. Or I can do some mathematical function between the two values that I get, okay? And one of the biggest use cases is, of course, to use the minimum. So here what we propose in the draft is this kind of behavior of choosing, I would say the reference value is controlled by configuration. So we can say that, yeah, I want to use only the remote, I want to use only the local, or I want to use a mathematical function between the two. And the last use case is about cumulation. Okay, so if you remember the example, we first initialize the link bandwidth community. So we have AG1 and AG2 setting the link bandwidth extended community with respectively 800 and 300. Then we have the T1, which computes the actual contributing bandwidth for each path, taking into account, in addition to what it received, the local link bandwidth if we configure it this way. Then T1, which is the first layer of the data center, will have to advertise down this aggregate that we receive from the DC2 down to the next layer through the T2. So the question again is, what is the link bandwidth that we will actually send to the T2? And one of the use cases is to say, okay, my T1 is currently doing WECMP. It's doing WECMP taking into account, I would say that it has 600 gig of traffic available to AG1 and 300 gig of traffic available, of bandwidth, sorry, available to AG2. So in total, it has 900 gigabits. Okay, so it can advertise, for instance, if we take the minimum, it could advertise 900 gigabit to T2. So it's doing what we call cumulation. So we sum the bandwidth available through all the paths, and we send the sum of all the paths. So next steps is we are welcoming feedback on the updates that we have done. So if you have concerns about anything that we have written, if you have additional use case that we need to consider, feel free to raise your point. We want also to check with the working group if we are fine going with standard track with this draft. So the mechanisms that we describe are purely local, so it doesn't really require any interop, but yeah, we can consider that. Now speaking as chairs, we had a discussion with IDR folks to actually make this document moving to IDR, because it's really a companion document to the link bandwidth draft. So theoretically, it's better to have both documents in the same working group. So the discussion is ongoing, and this presentation will also be done in IDR tomorrow. Jorge?
Jorge Rabadan, Nokia. Yeah, thanks for the presentation. So related to the last bullet here you just mentioned, so on paper I would say yes, it's an IDR draft, but I found a sentence which is a bit vague in the draft, and it says some of the use cases might be applicable to IPVPN and EVPN families as well. So my question to you is, are you guys thinking about any of the, there are 3 use cases explained, so any of those are applicable to IPVPN or EVPN, or, because also depending on that answer, the draft could move to IDR or maybe stay here. I don't know.
It could be applicable to IPVPN and EVPN as well, and as well to the, I would say, IPv4 unicast, IPv6 unicast families.
Okay.
Nothing prevents to use the BGP link bandwidth community for.
Yeah, no, but the use
Yeah,
cases that you have here.
maybe I think Jeff has something to say on that.
Yeah.
Okay.
No, my point is that normally if you use IPVPN or EVPN, it's because you are in multi-tenant data centers, and normally you don't change the next hop on every speaker, right, along the way, and you need the next hop self to actually insert the link bandwidth extended community. So that's why I was wondering if there is a use case or not for this. I mean, especially for the tweaks that you are talking about in this draft.
Agree. Yeah, no. Of course, the accumulation, yeah, it's more for hop by hop DC fabrics.
Okay, thank you.
Hello, this is Eduardo from ICANN. I have seen a couple of use cases here that is only on layer 1 apparently, because it's aggregations and direct connection that is 800 gigs and 600 gigs or something. Is there any way that you can actually do this community weighted, but in IBGP's connection? Like, for example, I have 4 routers that they are sending Anycast networks, and they are doing ECMP, but I want only one of them to be able to grab all the traffic and not all of them. I don't know if I'm explaining myself.
Not sure to catch your point.
Okay, so it's because I have 4 routers
Yeah.
that they are advertising Anycast
Anycast,
networks,
okay.
right? So I want to be able to tell those routers that I only want to send like 10 gig of traffic to one of these 4 servers and not the 4 of them, right? So
Yeah.
I can balance them.
Yeah.
Today, I'm sending all the traffic that they can take, basically.
But if you attach a different link bandwidth community to each of your Anycast advertisement, you will do WECMP to your Anycast destination, isn't it?
Would it be? Yeah. Yeah, that would be. Is that like a consideration in this case or something?
Yeah, I think there is one use case which is described in the draft, and this is one of the very old use case which has been there for a long time, which is I have bunches of servers on one cluster, and so I'm advertising a VIP which is reflecting the amount of actual workloads that I can attract on this particular server. So yeah.
Okay, thank you.
So Jeff Haas wearing my IDR chair hat this time. So the problem we have here in terms of group ownership is it mostly doesn't matter. From a process perspective, we certainly want the work to progress. But this work has to be co-owned. And it's for exactly the conversation you're having. These use cases keep on piling up, and a significant number of them are popping up not for core BGP purposes, but for things that are overlay, underlay, VPNs, etc. And IDR doesn't own all the use cases. So
of course, yeah.
This is expected. So where this lands, I don't think is going to be terribly important, aside from making the chairs all collectively happy.
Anyway, as long as we continue to discuss all together between IDR and BESS, the zone doesn't really matter for me. But
yeah, and just towards this presentation and somewhat nodding toward the presentation tomorrow, the point that's worth raising is that we know that link bandwidth that is specified right now as a generic piece of plumbing is vague. Is this for the overlay? Is this for the underlay? And the answer is right now it does all of these things depending on context. This is why we have a different link bandwidth type application for VPNs, I think EVPN if I remember right. And what I expect the use case that BESS in particular want to start considering is, as you start trying to draw circles around the layers, distinct for underlay, overlay, VPN context, and as you're leaking across VPNs, we're probably going to end up with needing some level of scoped behavior, different than transitive, non-transitive BGP, but is this for a application layer? And no, that right there and its interactions with this more generalized community is the long-term work.
Okay. Thank you. Gian?
Yes. Hi, can everyone hear me?
Yeah.
Okay. Hi, my name is Gian Mishra, and I'm presenting this draft on IPv4.
Can you try to speak a bit louder?
Oh, sure,
Because
sure.
we can hear you, but it's a bit low.
Okay, sure, sure. Hi, my name is Gian Mishra, and I am presenting this draft on behalf of co-authors on IPv4 v6 PE all SAPI. I think I can, thank you. Okay. So the updates on interoperability testing. So we've made some really good progress this past year on this draft with Interop. At the beginning of this year with MPL's World Congress, we were positioned to have this draft tested Interop. We did run into some issues between Nokia and Juniper. It ended up being an issue with on the Juniper side with next hop encoding with IRC 5549 and 8950, and we retested in the lab and on MX 960. It was resolved in 24 code. On the code that we had, we were able to successfully do all the tests. So everything completed successfully between Nokia and Juniper. We had done some tests, so we're in pretty good shape. I think with Nokia and Juniper, we've got all the testing done. We've done the interop, and everything looks really good. So we're still working on Cisco, doing the interop testing, but we're trying to finish the Cisco-specific Cisco to Cisco testing. I had some testing that I had done. This was on virtual with XRD, and that actually was with the VPN IPv4 SAPI. And I went through all the test cases related to IPv4, and that was completed successfully. I actually, at the time when I had done the work, I had not, it was on an SRv6 data plane as well as MPLS data plane, but I did not realize that I was actually doing, that this use case was actually part of my work. So it actually completed successfully, and that was really exciting. So now what's remaining is we're trying to finish we have Cisco ASR 9000 and then NCS. We're working on interop between Juniper, Nokia with Cisco, and so planning for end of the year, and then hopefully we're going to try to tee up for ENTech interop for next year. Next slide. So just to give us a summary, so basically Cisco was trying to finish up this year. Juniper and Nokia were in good shape, and Huawei, I think at this point, is off the table. So we really have just those three vendors that we're trying to do. We have two wrapped up, and then Cisco we're trying to finish off the testing this year. Next slide. So this slide was related to type SAPI. I'm not going to get into it, but in the draft we have a section that talks about it. So the draft is called V4 V6 All SAPI, where you can do the eBGP peering using the RFC 8950 next hop encoding, and we're able to on a V6 only peer you can carry all SAPIs, and there's tables in the draft that talks about it, but the one type of SAPI that we've excluded in there is typed NRO. And so, and there's the list of the ones there, and that's in a section in the draft. So this is just details related to that. Next slide. When we did the testing at so testing that's going on right now, and as well as the testing with Cisco and Nokia, it was over SRv6 data plane, and we were able to complete all of this successfully. So everything worked pretty well. We're still working on the Cisco one, but Nokia and Juniper, everything completed successfully. Next slide. So we're wrapping up the POC testing, and then we're planning for us work with last fall, shooting for the springtime. Thank you.
Thanks, Gern. Just a comment on this, that we were kind of looking at the structure of the draft, and we were wondering, so it contains kind of three areas. There's the sort of specification side of it, there's the test cases side of it, and there's the results of the testing. And so we may want to look at which, and the whole thing is in a standards track draft at the moment. So we may want to look at, just to sort of think about how to structure this going forward, to get, and what should be published at the end of the day by the IETF here. So one suggestion we have, and we need to sort of discuss this in the working group, is maybe taking out the specification part of it and publishing that, or taking that forward as standards track. And then there's also the kind of test cases part of it that would probably normally be sort of informational. There's also the testing results, which aren't normally published necessarily in an RFC of any kind, but maybe we can put those in a wiki, similar to kind of the interop testing or the stuff that the IDR has done with their wiki.
Right. Thank you.
Yeah, we'll kind of have a discussion with you and within the working group about that. Any thoughts?
Appreciate it. Thank you, Benson.
Okay, thanks.
Okay, next, I'm going to present this EVP and multi-active multi-homing on behalf of co-authors, Chang Wang Ling and Jorge Rabadan. We actually had more people involved in the discussion, so when we publish the next revision, we may have more co-authors. So quick background, EVPN already supports all active or single active multi-homing. On the right side, I have this picture here, the CE1 at the bottom, multi-home to PE1 to P2, PE3. In the all active mode, all the PEs on the multi-homing Ethernet segment, they can forward about unicast traffic, and the ingress PE can load balance to traffic to all of those. But only the DF will forward BOM traffic. For comparison, in a single active mode, only the DF is active and forwards traffic, whether it's unicast or BOM traffic, and others are inactive. There's no balancing from the ingress PEs. There are situations where an operator may want to have a hybrid mode. For example, in this case, PE1 and PE2, they are active and then they can both forward the unicast traffic, but PE3 is inactive and does not forward traffic at all until PE1 or PE2 or both of them fails. So that's the target use case. So we introduced this multi-active multi-homing concept, where a multi-homing segment has a set of PEs in the all active modes and another set of PEs in the single active modes based on the configure preferences. A PE can move from one set to another. For example, previously PE3 was not preferred, it was inactive in single active modes, but then it becomes preferred, moves into the all active set when PE1 fails. How do we achieve this? Basically, all the PEs on a multi-active multi-homing segment, they are provisioned with a preference value. That preference value is signaled in the DF election extended community in the Ethernet segment routes. And based on this preference value, the PEs on the multi-homing segments, they will realize whether they are preferred or not. So those preferred PEs will operate in the all active mode, and they signal P bit as 1 in the layer 2 attribute extended community. That is in the Ethernet AD per EVI routes. The ingress PEs, they will notice that there are multiple PEs signaling P equals 1, the P bit 1. So they will load balancing traffic to those PEs. The non-preferred PEs, they will operate in a single active mode, and they signal P0 and B0. As a result, remote PEs, they will not load balancing traffic to those ones. So that's the basic mechanism there. There are some details there. So only the PEs on the multi-homing segment needs to understand this new mode, and they set the P bits accordingly. And other PEs, like ingress PEs, they will just act on the signal, the PB bit as usual. They do not need to be aware of this multi-mode concept. And the preference value is signaled as part of the DF election community, even if we're not using the preference-based DF election. But if we are using the precedence-based DF election, there's no change. And if you're not using the preference-based DF election, we need to have a small change in the DF election algorithm. The reason is that those non-preferred PEs, they are inactive, so we don't want any of them to become the DF. There is already DF election capability there called the AC influence DF election capability, basically where you can consider the layer to the Ethernet AD per EVI routes. So here we add one condition there. If you see a PE signaling P equals 0, then you consider that PE as ineligible for the DF election. So you do not consider that one at all. That ensures that non-preferred PEs will not become elected as a DF. So one question could be that why don't we simply signal P equals 1 for both DF and BDF instead of have to signal the preference value and set the P bit based on that. And also, regardless of how the DF election is done. So we consider that, and it does work, but has two caveats. One is that if you only need 2 active, then that works. If you need to have 3 active, 4 active, that means you will have to do more backup, or backup DF election. That is one problem. Another problem is that it does not work well, for the strict modes, multi-active multi-homing. I will explain the strict mode versus loose mode in the next slide. Okay, so let's look at one example. We have 4 PEs. They have preference 100, 180 NT respectively. In the strict modes, only the most preferred PEs are active, and actually they all have the same preference value. For example, if PE1 goes down, now we have PE2 with preference 100, PE2 and PE3 and PE4 with preference 80. In that case, only PE2 remains in the active mode. PE3 does not become active. In the loose mode case, we could have M number of preferred PEs that could become active. In this example, when PE goes down, both PE2 and PE3 will become active. So that's the difference between the strict mode and the loose mode. So if we simply based on the DF and BDF results to set the PBit, then that means that we cannot have the strict modes multi-active. So the next step is basically seeking comments, especially that we believe there is no backward compatibility issue on the remote PEs. Obviously, on all the PEs, for all the PEs on that multi-homing segment, they all need to understand the new mode. But the remote ones, they don't need to. But please help us scrutinize and make sure that we got it correctly. Thank you.
Krishna?
Yeah, Krishna Swamy, Cisco Systems. Can you go to the slide number 4? Yeah. I think the ingress PE load balance traffic to preferred PEs, right, which signals P is equal to 1. If I'm not wrong, right, in active standby case, there could be a transition case in which both the PEs can send the P bit set. Then the RFC specifies that the one you have received with the latest is what you have to use. So if both PE1 and PE2 sends P bit, that doesn't mean that it's going to do a load balancing. It is going to prefer the one with the latest. So the existing behavior might not work.
Okay, but there's one thing here. I just realized I skipped the last bullet point here. So even though the PEs that are inactive, that are not preferred, they act as a single active mode and set the reset P bit. However, in that ESI label extended community, they actually signal that they are all doing all active. So as far as remote PEs are concerned, all the PEs are doing the all active modes, but it will see some PEs with the PBit set, and that's where the no balancing will happen. So I think that should address the problem, but we can follow up.
Yeah, I think we can follow it up because my belief is there is a behavior change. We need to do it on the ingress PE, but we can take it off.
Okay, thanks.
Ali, you wanted to say something?
With respect to the use cases, it is
Speak on the mic.
With respect to the use cases, it's not quite clear the use cases. So if upfront the use cases are specified, it would help a lot. And a question that I have is, are we trying to basically do the flexible LACP that it can do M4N redundancy? Like you can have N links in LACP and then you can pick M of them. Okay, or is it something beyond that? So I didn't get the feel for it from reading the draft.
I actually have a little bit trouble hearing you clearly, but I understand the question is about use case.
Right.
We can follow up separately, but in the simple view here is basically that you have a bunch of multi-home PEs there, and you only want traffic to go to some of them, but others don't forward the traffic at all until those active ones they fail or whatever. So that's the use case in the simple view, but
right.
we can clarify that.
We can chat offline. It
Yes.
just I'm talking with respect to the LACP protocol, link aggregation protocol. It has M4N redundancy. So I'm wondering whether you're trying to do that with the EVPN.
When we started with, it didn't come from that. Maybe it just happens to be the same, but we didn't start from that.
Okay, all right.
Yeah.
So we can talk offline.
Patrice, I'm sorry, I locked the queue because we will be out of time for the other slots. Sorry. Next one is SRv6 OAM. Yeah,
Hi,
go ahead.
Chair. Can you hear me?
Yep, we can hear you.
Okay. I'm Xiaoqiu Zhang from China Mobile. I will present this draft titled OAM for EVPN over SRv6 on behalf of my co-author, Changwang Lin. Okay, first, background EVPN over SRv6, which combines the flexible networking capabilities of EVPN with the advantages of SRv6, not only enhances network scalability, but also achieves efficient data transmission and isolation in multi-tenant environments, which has been widely deployed in various scenarios. Next slide, please. Next, the OAM mechanism enables the prompt detection and the localization of data plane failures, thereby supporting the continuity of business services. For MPLS-based EVPN networks, the LSP ping mechanism has already been defined and standardized in RFC 9489. However, a critical gap exists in SRv6 networks that deploy EVPN. There is currently no effective OAM mechanism specified. To address that, we need to introduce a dedicated OAM mechanism into SRv6-based EVPN networks, which can achieve efficient data plane fault detection and improve the level of operation and maintenance automation. Next slide, please. Firstly, we have designed the EVPN SRv6 ping procedure based on the existing RSP ping mechanism and tailored to detect data plane failures in SRv6 EVPN networks. To support this ping procedure, we have defined two encapsulation formats for the OAM ping packets, both using the MPLS echo request and reply packet structure. The purpose of this OAM ping packets is to probe and verify the SRv6 path, ensuring the quality of network slice. Next, thank you. Next, let's look at the first EVPN SRv6 OAM ping encapsulation format with a two-layer Ethernet header. The external Ethernet header and external IPv6 header are responsible for encapsulating the destination and the source MAC addresses, as well as the IPv6 addresses of intermediate forwarding devices, respectively. The segment routing header carries the forwarding path information through a segment list within SRv6 network. And the internal Ethernet header uses a virtual MAC address to encapsulate the destination MAC address. The internal IPv6 header encapsulates the destination IPv6 address, which is implemented using a loopback address. For the UDP header, in accordance with RFC 8029, the destination port must be set to 3503, a port number assigned by ANA specifically for MPLS echo requests. Finally, the MPLS echo request and reply serves as the core information of OAM ping packet. The content contained in this field is consistent with the specifications in RFC 9489. Next slide. The second OAM ping encapsulation format adopts a one-layer Ethernet header. It includes the Ethernet header, IPv6 header, SRH, UDP, and MPLS echo request and reply. The content of this one-layer format is largely consistent with the two-layer Ethernet format. The key difference is the absence of the inner layer Ethernet and IP encapsulation. Next slide. At last, we'll summarize their differences, advantages and disadvantages between the two formats. This two-layer Ethernet header format brings two key advantages. First is double isolation. The internal and the external Ethernet and IPv6 headers are separated, which clearly distinguishes between forwarding path devices and virtualization target devices, which making it suitable for EVPN multi-tenant scenarios. Second is accurate addressing. Since the internal IPv6 header uses a loopback address and the internal Ethernet header uses a virtual MAC, OEM messages can be accurately delivered to virtual network endpoints. It also has some drawbacks. One is high expenses. The addition of 20 bytes and plus 40 bytes leads to packet bloat, which affects the transmission efficiency. The other is high complexity. Network devices need to pass multiple layers of packet headers during processing, which may increase the device processing latency. A second pin encapsulation format with one layer Ethernet header has its own advantages. The first is conciseness and efficiency. It saves approximately 60 bytes of overhead, which not only improves bandwidth utilization, but also makes it well suited for high-performance networks. The second is low latency processing. Devices only need to pass a single layer of Ethernet and IPv6 headers, which speeds up forwarding and reduces processing delays. And its main drawbacks is limited flexibility and debugging complexity. For flexibility, virtual network targets cannot be directly identified through explicit header information, though this can be implicitly expressed through SRH segment list. And for debugging, the lack of explicit virtual network hierarchy information makes it more difficult to locate and resolve issues during troubleshooting processes. So in conclusion, we propose the OEM mechanism and the two encapsulation formats provide a targeted solution to the lack of effective OEM in SRv6 EVPN networks. And depending on specific network requirements, such as multi-tenant isolation or high performance demands, we can choose the appropriate encapsulation format. And the next step is to request more review and feedback to improve the draft. Any comments are welcome. Thank you.
Zafar, go ahead.
Yeah, Zafar Ali, Francisco Islam. So I'm the original editor of the 9259 SRv6 ONM draft. And it actually, the ONM in SRv6 relies on the IPv6 ONM capabilities. And there is, so ICMPv6. And there is a big difference between the way MPLS ONM works and IPv6 ONM works. But that's something for discussion at 6-man. So from BESS point of view, I don't think this draft can start here as the starting point. The other point is that I want to just emphasize, and I must admit that I did not follow the full details here, but anything related to ONM, data packet, and the ONM packet should always follow the same data path. in the network. So so I missed some of the part regarding the encapsulation. Thanks.
Thank you. Maybe we can discuss it later in the mailing list.
Absolutely. Thank you.
Thank you.
Greg, go ahead.
Hi, Greg Mirsky Erickson. I do share Zafar's question about what the scope of this OEM, because if it's a Service 6 tunnel, then ICMPv6 is a known mechanism, and it's been discussed in a 6-man group and Spring, so it should work without any additional complexity. Then if it's EVPN with the Service 6 tunnel, that seems that first, so the sender of EVPN ping will encapsulate it, and then it will be encapsulated in the Service 6. So again, that seems to be a known procedure, and I cannot see what's been standardized here in this document then. Okay, so we can discuss it on the mailing list. Thanks.
Okay, thank you.
Okay, let's move to the next presentation. Jorge.
Thank you. All right, so this is the ingress application bound flag in VXLAN. It's a short draft that Ali and I have been working on lately. So this is basically, it's an old issue, it's not a new issue. The idea is that when you have all active multi-homing in an Ethernet segment, you are flooding a known unicast, you use ingress application, and the MAC has not yet learned by the ingress PE or the remote PE, you may have a packet duplication on the Ethernet segment or on the CE that is multi-homed. So this is documented in RFC 8365, section 833. But the recommendation done by the RFC was basically to use VXLAN GPE with a special flag that is marking the ingress replicated bump frames. So the question is, why didn't RFC 8365 define the B bit in VXLAN? Well, because VXLAN or RFC 7348 was an independent submission, not an IETF-sponsored document, but that is being fixed with RFC 7348 BESS, which is making VXLAN an IETF technology, and it's actually requesting the creation of a VXLAN flags registry. So the goal of this short document is basically to request the allocation of the B bit in this registry and extend its use beyond the original RFC 8365 scenario. This is the bit, position number 6, which is basically the same as VXLAN GPE was using to facilitate the implementation. And that is basically indicating that the encapsulated packet is a BUM frame. And let me show you with an example. So the first scenario is what is documented in RFC 8365. The idea is you have CE1 multi-home to PE1 and PE2, with PE1 being the non-DF, PE2 the DF. So if MAC1 is learned on both locally, but for whatever reason, the advertisement didn't make it to PE3 yet. So if you receive traffic on PE3 from CE2 going to M1, because the MAC is not known, basically PE3 will ingress replicate the unknown unicast packet to PE1 and PE2. But you know, if you don't do anything special, because the MAC is known on both, both will forward. So that is the packet duplication issue that happens on non-upgraded PEs. If you have the PEs following this spec, there is no duplication, because in that case, PE3 is setting the flag, And then P1 and P2, they look at the flag and they say, oh, this is a BUM packet, so only the DF will forward, and you avoid the duplication. The second scenario is actually the opposite. So P3 knows the MAC address, MAC1, but for whatever reason on P1 and P2, the MAC aged out, right? So it's not there anymore. So P3 receives traffic from CE2, picks one of the PEs because the MAC1 is associated to the remote Ethernet segment. So it does the load balancing. So suppose it picks P1, but now P1 does not have the MAC address and it's the non-DF, right? So it won't forward. So you have some transient packet drop. So you can avoid that with this specification. So when P3 sends the VXLAN packet, it will not set the B bit. And then basically P1 receives the packet. It sees that the B bit is unset. And it knows, can identify the packet as, originally being unicasted. And therefore, it's safe for P1 to forward to CE1. So that's about it. I think this signaling can be also used in other scenarios, other use cases, but yeah, we'll see. And basically, we want to request some feedback from the working group. Any questions?
Hi, I'm Sharif from Siena. Thank you for that presentation.
Speak in the mic, please.
Oh, sorry. Sharif from Siena. Very quick question. What happens in the case in scenario 1 when, say, PE1 has the MAC, but PE2 doesn't? Like, have you considered that scenario that possibly one could receive it and the other doesn't? And what would be the behavior in that case?
Well, you have the signaling from the source PE, right? And you know that it was ingress replicated. So basically, on the two multi-home Ps, that was ingress replicated. So which means that only the TF should forward anyway.
Okay. I just want to make sure that, because in the scenario, you always had the case where either they both learned the MAC or they both didn't. But you didn't have the case where one learned it, one didn't. So I just want to make sure you considered that scenario in the
And the procedures are basically specific to the node anyway.
Okay.
So one node doesn't know that the other one has the MAC or the other way around. So yeah, it's basically on the bit in the packet.
Okay, perfect. Thank you.
Thank you.
One very quickly.
Yeah, very quick. Okay, just a minor comment. B bit is very much needed. I totally agree with you guys. So on slide 3, the last bullet point, you say if data packs come with a B bit equal to 0 must be treated as a non-unicast. It is true for router support this draft, but maybe consider the pre-released routers does not support that. The muscles maybe need to be.
Yeah, actually, when I was reading that sentence, it's really not accurate. So yeah, I actually avoided to talk about it during the presentation.
It's just
but,
a minor comment.
But yeah, I don't think it's written like that in the draft. But yeah, we can discuss. Okay, so this draft, we've presented this multiple times. Actually, the last one in Madrid, and we said that we would do something, and we've actually done something with it. So I wanted to go through the changes. This is version 7. Just a short refresher. So prior to this revision 7, so what happened is that this document was informational, did not create any new procedures. And basically, the idea was to summarize the impact of interdomain option B connectivity in some EVPN procedures, right? Including layer 2 and layer 3 services and even PBB EVPN. There were some issues analyzed, and potential solutions offered, but that was about it. Now, one of the main issues that is analyzed in the draft is that the AD per ES route does not have an identifier other than the next hop. And obviously, when you are in an interdomain option B network, the next hop is being rewritten along the way by the border routers. So you actually lose the identifier, the source identifier of the egress PE, right? And that has some consequences. And the example you have here in the diagram is for mass withdraw, per ES mass withdraw, right? The per ES mass withdraw basically requires on the ingress PE to correlate the MAC IP routes along with the withdrawal of the AD per ES route from a given PE to actually invalidate those MACs, learned from that egress PE. Since you are losing the context of the AD per ES route, you cannot make that correlation, right? So, and that has also impact not only in this per ES mass withdraw, but also in some other procedures like aliasing and backup path along different domains, or the AC influenced deflection capability, or even the E3 egress filtering for bump traffic, right, originated from the leaf. So the document in the prior revision basically was given some, multiple options, but we believe that we need to, come down to a single solution to avoid interrupt issues, and that's what we are doing. And we've come down to a point where we need to have the solution ready to avoid all those issues. So what we've done in version 7 is, first of all, to have a solution for this. There were different options, and the best option that we decided to include in the draft is to define a new sub-TLV for the BGP tunnel encapsulation attribute. This sub-TLV is called egress PE identifier. We are requesting IANA for a new code point for it. The format is similar to the tunnel egress endpoint sub-TLV, which is in RFC 90112, but obviously it uses different code point and the semantics are different. Now, one of the reasons why we are not reusing the tunnel egress endpoint is because in some documents in BESS, we are using the tunnel egress endpoint, and we might want to have both the egress PE identifier and the tunnel egress endpoint sub-TLVs in the same tunnel TLV, right? And that is one of the main reasons. So the procedures with this new sub-TLV in the BGP tunnel encapsulation attribute is basically you set it at the egress PE, you encode it in the address subfield, and you advertise it along with the AD per ES route, also the MAC IP advertisement route, and the IP prefix routes. At the border routers, you may add, if the route that you receive does not contain the egress PE identifier and you are the first border router, you can actually include this sub-TLV and derive it from the next hop. And but if the route comes with the sub-TLV, basically the border router should not, or actually must not, modify the sub-TLV. Now with that, the ingress PE, it'll receive the routes, and now it has a clear identifier for the AD per ES route, and actually can make the correlation between routes and can solve all the issues. The other thing that we changed, that we need to highlight, is that because of that change, now we actually converted this document into standards track, and it's no longer informational. So what is next? We probably need more details in the for the new sub-TLV that we are defining. We'll look at the guidelines that Sue has in her templates draft, and we will require some feedback from the working group and see if we are missing something or if we have some issues with this. And with that, yeah, we want to request this working group adoption as soon as possible because it's a real issue that we need to fix. Any questions? Okay, thank you.
Thank you.
Hi, my name is Wen. I'm going to present proxy MAC IP advertisement in EVPN on behalf of all the co-authors. Yeah. So first recap of the potential problem in the EVPN network. This is really applied to all to EVPN multi-home network. And showing the example here, we have end host multi-home to a set of PEs for redundancy and a load balance. And due to the load balance hash algorithm implemented by end host, as you know, MAC plus IP maybe only be learned by a subset of multi-home P, or more often it's only learned by only one of EVPN, multi-home, the EVPN P. In this case, is a P1. So the potential problems we're trying to address is when there is a failure in the network, either is node failure or egress link failure, like the P1 to the end host. So potentially the MAC IP binding information can be lost. So when this happens, they could potentially incur unnecessary flooding, traffic blackcalling, or up NS suppression or stop function on all the EVPN PE. So this draft proposed MAC IP advertisement solution to trying to avoid all the potential problem I just mentioned before, but just want to be clear, because there was a confusion before. This is not the first time we present that, what this draft is about. This draft, the solution is not about how to address fast reroute for in-flight traffic. This is really about trying to avoid the race condition which cause all the potential problem I mentioned before. The race condition basically between MAC IP retention timer and the MAC IP rerunning. Because if not rerun on the specific time, we lost all the MAC plus IP binding in the network, the information in the EVPN network. So a quick update, since last revision, we added a co-author, Ali Sajasi from Cisco. We also documented for symmetric IRB use case, we explicitly specified the proxy MAC IP advertisement need to attach both route target for MAC IP as well as for IP verb, so that in case a PE only has IP verb but does not have bridge domain for the MAC, which attached to can still work for this solution. And we also specified a single active proxy MAC IP. This solution still work upright. Also, since the last revision, based on the comment in the mailing list, we added detailed explanations. The traffic blackcalling or excessive flooding due to the race condition can be applied to both node failure and the egress link failure case. Show as an example before, I say this P is the only one learned MAC plus IP binding through the data plan locally, and it is the DF. And in case the P suffer node failure, and suppose the remote PE not on this multi-home segment choose the P1 to forward the traffic to the end host. So when node fail, they still keep send the traffic to P1, and we could have traffic blackcalling. Or in case the race condition happened, P4P, the remote P delete the MAC binding information because it's not able to learn those MAC plus IP binding in time, so it become a non-unicast traffic, become a bomb traffic unknown, like flooding. And so we could have race condition here, like the new DF is elected, not elected in time, or it's elected but not programming the forwarding in time, so leads to traffic black holding. So this is a no failure case. Similarly, in the egress link failure from a P1 to the end host, well, the FRR in-flight traffic, does FRR, no change to that, no impact to those kind of traffic. But in case the MAC plus IP binding information is gone due to the race conditions take too long to relearn, then again, same issues as I mentioned in the node failure case could be, it's become flood, traffic will be flooded and potentially could be also black hole because the DF role programming in the forwarding. So quick refresh for the solution we specified in the draft. In this diagram, multi-home site is connected to P1, P2, and a P3. So look at this EVPN network. I will group this P, actually EVPN P, into two groups. One group consists of all the remote P not connected to the multi-home site. The other group is all multi-home P connect this to the multi-home site. In the stated case, let's assume P1 is the only PE learned a specific MAC plus IP binding through the data plane. That PE sync up the MAC plus IP binding to the rest of EVPN PEs. So two groups. The first group is multi-home PE. P2 and P3 in particular, they will advertise a proxy MAC plus IP advertisement. What is proxy MAC plus IP advertisement? It is actually basically just a type 2 MAC plus IP advertisement, but only with a proxy bit set. And this proxy bit telling the multi-home peer that the originator, say P2, he has a proxy MAC advertisement. This P bit signify to the rest of the peer multi-home Ps, I did not learn this MAC plus IP through the data plane. I learned that I'm advertising because I'm proxy. I'm learned that because I learned from a control plane somewhere, from other Ps. So this is this group, multi-home P, but the other group, remote P, not on the same ES, proxy bit does not have any significance. They treat proxy MAC advertisement versus non-proxy MAC advertisement the same, use the standard EVPN procedures. This is in steady situation. Now, a failure occurs in the network, either a node failure or egress link failure. And a P1 will quickly invalidate and withdraw this particular non-proxy type 2 MAC plus IP advertisement. So what happened to P2 and P3? P2 and P3 quickly realize there is no other peer multi-home PE actually has learned this MAC plus IP through the data plane. They realized that they quickly triggered up or NS message for IPv4 to relearn the MAC. They also start proxy MAC each time, okay? So if for one of the peer multi-home P, the P2 and P3 can relearn the MAC in time or through the non-proxy MAC advertisement from his peer, then they just cancel the aging timer. So if in the condition they relearn, because it's a local learning, it's much quicker than other PE learning. It's just a locally learning data plan. If they relearned, what happened to the other group, the remote PE? This is remote PE will do nothing because even temporarily, nobody learned the MAC plus IP from the data plan. Remote P sees nothing because P2, P3 does not withdraw the proxy MAC, and the remote P3 does not look into the proxy bits at all. So nothing happened to the remote P. So this is very significant. The advantages bring, consider in the skill setup, remote PE no longer will rely on the control plane to refresh its MAC plus IP binding. Otherwise, he may have a little retention time. He has to wait until one of the multi-home P to send him this type 2 MAC routes and a process and a refresh its MAC plus IP binding in full. So this is really, again, in the skill network, remote P does not need to do anything. If the PM multi-home PE can relearn the information quickly. And also the learning happen is only, the action is really the multi-home PE, the rest of the network does nothing, right? So this is in the scale situations really help. That's really the advantage to using the proxy MAC advertisement. But in case something is wrong, nothing come back, no reply come back from the end host, then the age time for the proxy MAC will be expired on the P2 and the P3, then they will withdraw the proxy MAC plus IP advertisement, then just the normal process on the remote P cleanup, right? So this draft has been published for a long time and being adopted by many vendors, including FR routings, and also deployed in the field for a couple of years. So also we'd like to seek work group adoption. Yeah, thank you very much.
Krishna, go ahead. If you can be quick with your comment.
Yeah.
How many minutes are left?
Yeah, thanks, Ben, for making progress on this draft. So I couldn't find the information in the draft on how does the multi-home piece handle the proxy bit. You mentioned it in the presentation, but it is not present in the draft. It is better to add a separate section to how does that handle. Go ahead.
Yeah, so it mentioned like it's track if anyone means his peer multi-home CE has a type 2 advertisement without P-bit set. So that's how it's tracked. Because if nobody send a non-proxy, regular type 2, it means this MAC IP, the data plane learning is gone. So they need to take action, trigger the op, neighbor solicit message.
No, I think my question is different, right? So if you go back to the slide number 2 or 3, maybe 3, yeah, right? So in this case, like, the PE or maybe the 2 is better. Yeah. So let's say the PE1 is the one where the local learning has happened and the PE2 and PE3 are the ones which are sending the proxy bit. Now what happens on PE1 when it receives the MAC IP with the proxy bit? What does it do? At the same time, PE3 also originating a MAC IP with the proxy bit, but it is also going to receive the MAC IP route with the PE2 with the proxy bit. What does it do?
Oh, you mean
that needs to be clarified.
The node suffer, the PE suffer the failure.
No, there is no failure happen in a steady state, right? When it receives, what is it that it has to do by looking at the proxy bit? Should it drop it? Should it keep it? Right? So that clarification is needed in the draft.
multi-home P will will recognize the P bit, will process the P bit. In the in the steady situation, he will just behave as is in the forwarding. It's pointing to his local access for the
That's in the hardware,
forwarding.
but what happens in the control plane? In the control plane, they have to keep the local copy plus the proxy copy also additionally. That needs to be clarified. On the remote, it's fine. Remote has to keep all the 3 entries in this example. But in the local, what is that behavior?
It is like a multi-home the P. If you will learn the P locally, let's say forget about proxy app.
Okay.
On the multi-home P, you learn the P locally, you learn the P from another peer, your own peer multi-home P. he will using this, he will know this is this is only for multi-homing purpose, same procedure is using. Yeah.
I see.
Nothing new.
Yeah,
I think, there are some.
Can you try to close this
Sure,
offline?
sure.
Because
There are
there is
some
another
error cases.
comment.
To miss the Saturday you're trying to bring, we can.
Yeah, we can discuss this.
Keep up,
There
during
could be
the-
a loops which could happen in some scenarios where on the PE1, when the link goes down and it clears his local MAC IP and link comes up immediately, and on the PE2, PE3, if the ARP and the ND has not got the response, they all think that it is reachable.
Yeah.
So there are some
If
scenarios
you,
we can discuss.
if you just can close it on the list, because we are out of time.
So let's discuss over the mailing list.
Yeah, Nitsan, if you can make it very quick, if you don't mind.
Nitsan Ribbon, just a short question. Why not have just P2 and P3 send a kind of ARP, and following which they will get response, and they will advertise their route type 2?
Yeah, so that's a good question. And the
It seems much simpler to me anyway.
So let me address your question. Thank you for the questions. So there's a MAC aging timer, let's say X minutes, okay? Usually you don't want actually cause actual activity when the network is stable. Let's say X is 10 minutes. I'm just making things up, okay? But really, the failure occurs in 1 minute. You don't send up until maybe 9 minutes. It's all about to expire. Let me send up. Yeah, I agree with you. They will send up before the timer expires. But network failure occur in the first minute. Then you have to, what tell them to send up is when you see the MAC withdraw, then you send up. This is for this multi-home group. But the whole purpose of this draft is you don't want to impact the remote PE. What's remote PE, P4 and P5 on PN in this diagram? They have to refresh the MAC plus IP binding within certain time. If the only one receiver withdraw, they can hold for whatever the fast failover convergence. Let's see, I'm gonna hold in for 15 seconds or 1 minute, but that's the race condition it occurs. If a P2 send up and he learned that, then he had to send over the control plane to P4 and P5. Especially in the skill setup, P4, P5 have relied on the control plane process, say, somebody else send me that, then I will not delete my forwarding entry. This process can take long in the control plane in the scale setup. Vices with this proposal, remote P does nothing because he never see this MAC IP withdrawal. He does not distinguish whether there's a P set, P bit set or not set. He does not distinguish that.
Okay,
So he does nothing. So that's the advantage for that.
Okay, thank you.
Thank you very much.
Let's move on with the next slot, SRv6 Anycast. Yeah, we just have 15 minutes left, so if you can absolutely stick to your 5 minutes. Go ahead.
This is Chan Wanling from New HCC. This draft is about SRv6 Anycast VPN services. Next slide. So background, in multi-home scenarios, egress P can access each other by unicast services. Ingress P can send traffic to egress P in load balance mode or active standby mode. So the egress P may need to assign and advertise multiple services, anycast services and unicast services for the same service. Currently it is unclear which services are anycast and which are unicast. So this draft describes the use case for anycast services and define the anycast flavor for SRv6 services carried in BGP update message. Next slide, please. So we can see the first scenarios. on multi-home, the egress speed achieve the load balance and simplify the network deployment when we can advertising unicast services between multi-home the egress speed to form the protected services. So the details as follows. Both P2 and P3 advertise both the Anycast and Unicast services, and P1 can use the Anycast services. So the traffic can be forwarded to P2 and P3 in load balanced manner, and both egress P2 and P3 can access by each other by unicast service. Next slide. So this another use case. We can use the Anycast SRv6 policy and Anycast SRv6 services. When deploying SRv6 policies may be established between all the ingress P and the egress P. As the number of P's increase, the number of SRv6 policy also increased. Therefore, we use the Anycast SRv6 policy and Anycast services to achieve the efficiency network operations. Next slide, please. So our solution is to define the Anycast SRv6 endpoint behaviors to enable the advertisement of Anycast services behavior together with behaviors used by VPN or EVPN. We defined 7 Anycast endpoint behaviors, such as end DT4 with Anycast and end DT6 with Anycast. Next slide. We can see the use case. We take end DT46 Anycast, for example. BP can advertise both Anycast services and Unicast services. So the P1 can distinguish the Anycast service and Unicast by a different SRv6 flavor. Next page, please. So the solution is quite simple, and we just define the new Anycast flavor. So we think the solution is simple and easy to deploy. So we are seeking for adoption code. Thanks.
Okay, thank you. Unfortunately, we have no time for questions. If you have any questions, please take it to the list. Ajun, you are the last one.
Hello there. Here I want to just present our update for the layer 3 access EVPN service. So there are firstly the recap of the proposed solution, and secondly the summary of the discussion on the mail list after the last meetings. So here is the recap of the requirement and our solutions. The requirement is focused on, the scenario is described here. There is one backbone, EVPN backbone, and there are several men that are layer 3 network. And one customer want to have different branch located behind the different men, and customer buy the backbone service within buy the backbone EVPN service at the backbone network, and want to connect their different branch together, and also keep the traffic isolations from the different branches. So we call it is the co-inco style communication style requirement. This is the customer requirement. And here is our proposed solution for the requirement. We want to connect this site under the man to the backbone via one side shoulder wire, for example, the VXLAN to transport the Ethernet frame to the piece of the backbone UVP. And we want to keep the identification of the side wire within the within encapsulation frame to different the traffic from the different branch. We call it is the layers LSI aware bundle service. So for such requirement, if the main are layer 2 network, it can be solved by the current VLAN aware service bundle service. But if the main is layer 3 network, we need to design one new solution to meet the customer's requirement. And after our introduction in last IETF meeting, there are a lot discussed on the mail list. So here just I summarize some key point. And from the expert from BESS, they provided there may be other solutions that can accomplish our aim. For example, the first RFC provided the virtual Ethernet segment for EVPN and provide a backbone bridge. We have studied this RFC and find that it is a similar approach, but can only suitable for the MPS network. And there are other experts from recommended to use another RFC for the virtual private wire service support in the Ethernet VPN, but it can only provide the P2P style communications. And other person Ali also provided the other solution. For example, use both the core VNI and VLAN ID and all the one core VNI per BD to solve the problems. But for the first proposal, the customer packet had no VLAN information. We must assign the one VLAN for their packet. For the second proposal, if we use a different VNI for the different BD, it is difficult to associate the traffic from a different branch to one customers. So we want to bundle their traffics. So we also investigate carefully for the current implementation for the VLAN aware bundle service in the RFC 7432, and we can confirm that from the current standard description, it can only achieve the VLAN aware bundle service in the control plane, but for data plane, it cannot achieve our goals because there is only one identifier within the encapsulation packet. So other person also propose use some double VLAN encapsulation. I see we have replied in the mail list that it is impractical. So for the conclusion, we think for the VLAN aware, for the for the VLAN aware bundle service, there is no bundle identifier in the data planes. So we think it is necessary for the new design for the what we call the LSI aware data aware bundle service. So here we just this is the proposal for the forwarding plane extension. So we define one new flag field to identify that there is one LSI identifier in the result field in the VLAN encapsulation header, in the VLAN encapsulation headers. And we also design one control plane extension to transfer the information of the LSI that is associated with the new ES type to or advertisement that this is the new type of the access Ethernet segment. So this is for the update and our discussion summary for the. So I think we after this lot of discussion, I think the time to make a working group adoption call. Thank you.
Ali, please.
So I just want to say that your conclusion is different than the rest of us. We had a lot of email exchanges, and both me, Sasha, Jeffrey, we all concluded that we don't need it, and this capability can already be done with the existing EVPN. So the question that I have for you, besides which other vendors you think have this issue? I mean, we're running VXLAN for past 10, 15 years. And if there was a gap, it would have been brought up somehow. So you're saying there is a gap, and I'm saying besides you, is there anybody else that's saying there is this gap?
So
because it seems like we are lucky we had all these exchanges, all the people are saying it is not a gap. You're saying there is a gap. And I'm saying besides you, is there anybody else's, any other vendors, any other provider sees the same gap that you're seeing?
I can discuss with other vendors for the gap analysis, because from our exchange and the mail list, we can make a conclusion that there is the current solution cannot meet our requirement,
What?
So
I mean, we say it in so many different ways that we can, okay? But you're seeing certain, it seems like from your glasses, you think there is an issue. I'm saying that besides you, is there anybody else that see the same thing?
I have summary our discussion at this slide. So I think if you say you can solve the problems with such solution or with other solution, I think you can provide the detailed explanation and
we
we can discuss later.
In the email exchanges,
and then you have provided several alternative solutions. We have analyzed them and find that they can't meet.
It is not just from me. I mean, Sasha came to the same conclusion as me. Jeffrey came to the same conclusion. Whoever was in that discussion came to the same conclusion.
Yeah, I have summary the proposal from Sasa. I think if he don't agree, I think he can provide her new
I'm wondering
solutions.
maybe there is a difference in, let's say, there is a disconnect in language. So if there is somebody else's that can explain that this issue besides you, because you're explaining in a way that we are saying that we don't see the issue. So I'm saying that it would be good if it is a real problem, somebody else has come and explained it that this is a problem.
Okay. I will let also the mic to Jeffrey to add on it.
Okay. I want to add to what Ali said. I do not agree with the conclusion. I do not agree with the requirements and the solution here. Indeed, many of us have individually have said on the mailing list that there is no point to continue the discussion. And also, indeed, I agree that here you brought up a new requirement, being able to identify the bundle. That requirement was not in the 10 revisions of the drafts. It was not in your first slide on the requirements. You made it. Right now, it's a requirement for identifying the bundle is the only reason that may be to continue this work. However, even that agreement, the requirement, I do not think it's needed, and that even if you do have a need for that, there is better solution there. But that is another discussion. Basically, for the original problem you were trying to solve in the drafts, in the 10 revisions of draft over this 4 years, we already have a solution for that. And again, just the bundle identifier requirement, that again is not really needed there.
Okay, I will find some time to discuss with you further. Okay, thank you.
Yeah, but so really speaking as chair, so this has been presented multiple times. Each time we got a lot of pushback during the meeting or on the mailing list from all the main experts in this working group. So honestly, I don't really see why do we want to pursue any discussion, because it seems to be a dead end anyway. You are not convincing the group, so.
Okay.
But yeah, thank you for the proposal, but.
Okay, thank you. I try to discuss with further Jeffrey. Okay, thank you.
Okay, thank you. So this was the last slot. Thank you for the attendance, and hopefully let's see you in China next time.